Static methods, class methods, class variables. So now we are moving towards another concept of object oriented Python, which is inheritance. So why we need inheritance? Like sometimes we define a class and we want to use that class methods and features somewhere else, so we need to rewrite the code. So it is a step in the direction of code reusability. That means once something is defined, we can use that in another class by inheriting the features. So it's a kind of is a relationship which extend all the properties of any superclass in the subclass. So that case, in that way, we maintain superclass and subclass relationship. So we can clearly say in case of inheritance, like any other property, if we inherit from our parents, we also have their properties, but also we have our own unique properties. So, or if any general thing could be inherited and then specific things could be added to the subclass. In that way, all the attributes and methods of superclass are inherited, becomes part of the subclass without writing them or without rewriting them. Okay, so general syntax of inheriting any class is if we define any class the same way we use a class keyword. If this is going to be a superclass having some attributes and methods, and if you want to inherit this superclass, then this subclass name, after this subclass name, within bracket, not square bracket, within simple bracket, you have to mention the name of this class which you want to inherit. So in general we inherit in this way: class name, any class which is already defined. Now this is the class that you want to define with inheritance. So definition and inheritance both are going simultaneously. This subclass is the name of the class that you are going to create with the features of another class. So the features of which class you are going to inherit, you are mentioning within this parenthesis. If we talk of an example, like suppose we have this class A. This class A is having some functions and this class B is inheriting class A. So all the features of class A would become the part of B, and this B is also having their own features. Okay, if I take any simple example, suppose we have a class A, and in this class we have one simple method display which gives a message. Self is required for instance method. So in this we are printing in A. So in A we are printing, this is the method of this class. Now we have class B which we are going to define, but this class B wants to have all the function methods and attributes of another class which is A here. So that means this A is inheriting class, so B class is inheriting class A. Fine. So inside this class, this particular class can also have their own function, display. Okay, display 1, let me call it display 1 self, and then what it will do, it will display that this function is in B. Okay, that's it. This column should not be here. So if we run this, now suppose we create object of class B. So how we create, let's say the name is A and B class name I am using here to generate the object, and again I run it. Obviously there will be no output, but just I wanted to show you something. If we write A dot, you can see both the functions. In the object of B class we are able to see function of A and B both. So any of these function we can use. Fine. This is very simple example, and you can see what is happening in this case. class A is defined some attribute. This is initializer where some message for defining that we are in class A. This is the instance variable of this class A, which is initialized to 10. Again we have this instance method. It will display that currently we are in the class A display method, and will display also the instance variable. Now this class B inheriting class A, print where we are in class B, initializer for class B with some instance value initialized, and display function for class B. So you can see displays here, displays here, both places we have same name. So there will be some ambiguity that which function should be called if we call this display function, even for initializer also. Fine, even for initializer it should there should be some confusion that we need to clarify. So suppose we create object. Here we are creating object of class B. As already told, whenever we create object of any class, that by default automatically executes the corresponding initializer. Now initializer is not mandatory to give in the class definition, but here we have given for both the cases. Now which initializer would be called? We are generating object of class B. So as per standard rule, it will first find the initializer in the that local class. If it is there, that would be executed. If it is not there, then the initializer of the inherited class will execute. But in this case we already had initializer for class B, that's why we are in class B. This is the output. We are in class B, and then using class B initializer is printed here, and after that this instance is initialized. Now what we are doing, object of B, this particular object's display function we are calling. Now again display is also A class and B class. As we inherited A class, so this display is also part of this B class. Now which display should be called? Again we have two functions with same name, so priority would be given to the function if it is locally defined. Yes, it is locally defined, so first display this particular its own original function would be called. Using class B display would be in the output. If this display is not defined and display is there, then this particular display would have been called. So this order we need to follow. So why it is written here, access local first, if not then of super, and so on depth wise. Fine. Now if still we want to call non-local function, for that, like in other programming languages, we have super function, super keyword you can say, or super function you can say. When we want to call the functions of super class, we use that. How we use that? Here the same code I am writing, but with some super function here in the initializer of class B, which should be called whenever we create object of class B, and if it will follow this initializer, it will find the statement super function, then dot, and then the name of the initializer in the upper class. So this method is being called using super keyword. So whenever we create object, this function is called. When this function is called, it encounters this statement, and by this statement it will move to the initializer of class A, and there it will complete these two instructions, return back. After this it will continue on this statement, and then we'll get this point. So what is the output expected in this case? Object of B when created, initialize called, this will be called, so it will move to here. First statement is this, using class A initializer. After that it will return here using class B initializer. After that this is initialized. Now if we call display, display is here, display is here, but we are not using super keyword, so display, this particular display function will be called here. So using class B display would be the output in this case. I hope it's clear how to resolve the ambiguity, like when we have same name function and which one to be called, preference would be given to the local one. If not defined, it will move to further. Fine. Next is, this was about single level inheritance. Single level, like only one class, super class, and at the next level we are inheriting only single class. That is single level. Multi-level means the class which is inheriting is not only subclass, but it is also a superclass from for some other classes. That kind of inheritance is called multi-level inheritance. This is the example of multi-level inheritance. Here what we are doing, we are having one class. This class is being inherited by B, and this B class is again inherited by class C. So what would be there? All the functions of class A or methods whichever defined will become part of class B, and all the functions of B will become part of C. That means A and B both will come under C. Only A will come under B along with its own function, and this A is alone without any inheritance. So we can check this. For example, if we take this example, now these are the objects of class C, A and B. If I type C object dot, let me compile it first. Now if we take object of C, you can see what are the functions available in C: display A, display B and display C, all, because we inherited A and B both. B takes all functions of A, C takes all functions of B, which is already having A. So all are available there. Fine. So this is about multi-level inheritance. These function, you can add any number of function, you can add any attributes, but you need to understand what are the properties that would be inherited. Next type of inheritance is multiple inheritance. Multiple inheritance means a class which inherits more than one class. So here we have class A, class B, and class C is not only inheriting one class but two classes, A and B. In that case, C will have properties of both A and B inherited. All the public members would be inherited. So class C function will also have display definition for B, display definition of A. So for identification purpose, I have written here print A, print B and print C for these display functions. Now I created object of all the three classes C, A and B. If we call C dot display, now there is ambiguity for three functions. We have display defined for class C originally, display defined for class B which is inherited, and display defined for class A which is also inherited. So three display function, which one will be executed? So here also we have that same rule, that first local definition is applicable. If it is there, then why you can see when we execute C dot display, it is executing for C, but when we call A dot display, it is executing its own function A, and when we call B dot display, it is executing its own function. No problem at all, because local function is given the priority and C's local function was C, this particular print C statement, that is executed. Now problem arises if we try to use the super keyword in order to call the super class function, but in this case we have two super classes. So which one class function would be called if we use the super keyword? In that case, suppose let me open this code. Suppose C class is inheriting A and B, and B is not inheriting anyone. In this case, if we use super keyword in this definition, super function dot display, that function name which we have used, let me name all the functions same. So display function, which display would be called? This is the query. What do you think? Let me create object of class C first and call C dot display. See what is output. A and C. First A is printed and then C is printed. So when we created this object, we call the display function. So display is locally defined, so it will move to the definition. In the definition we use the super keyword. So super will execute the super class, but there are two super classes, A and B. Now in this case, if we have multiple inheritance, in that case it takes the priority from left to right. Suppose there are 3 to any number of classes mentioned, so leftmost is given the first priority. If there is definition of this function, it would be executed. If not, it will move to the next one. And inside also, if we have multiple or multi-level, that will go depth wise. Okay, depth wise it will follow the functions. So in this case, A is executed and after that C is printed. That's why we are getting that output. So here also we are this is a simple example, and this is the example where we have tried multi-level with super keyword. So it will give priority to the leftmost class function and then move towards right. This is about multiple inheritance. So this is the rule that we use, and in this example you can clarify the same code I am writing here. If we created call this function display, first A is executed and then C is executed. So this is about inheritance in Python and their types. I hope you understood each and every concept. If any query clarification, you can ask in comments. Till then, thank you.